Hello, everyone. We haven't quite started yet, but we'll get started in just a minute or two yet as well. So just wanted to make sure people have a chance to join right now, and then we'll kind of get started solving some problems, doing some intro and stuff like that in a minute or two. Just to introduce myself, I know a lot of you guys might have joined this morning, but if you're here for the first time as well, welcome to everyone. My name is John Lensmeyer. You can call me Mr. John. That's usually what students call me in a teaching context. So I'm excited to be with you guys doing some word problems this afternoon. Little bit more challenging than what we did in the morning. So these are kind of more geared toward middle school students, right? So we're going to be doing some things with kind of ratios, percentages a little bit. Those are some topics that people kind of might have first been exposed to in middle school, or kind of are typically middle school kind of math levels that way as well. And so some of these, yeah, hopefully still pretty easy mostly, but we want to kind of make sure people are okay with the stuff, and hopefully there'll at least be some interesting problems as well. Okay, so yeah, like I said, we'll get kind of started in a second here. Yeah, if you have some issues, maybe rejoin, change the quality, or just let it kind of fix itself a little bit as well that way too. So hopefully everybody is doing well, staying safe, and things like that. And today, just to kind of get our minds off of things, hopefully we're going to kind of solve some fun problems together in the next kind of roughly 45 minutes or so. So, a little bit of an introduction, right? What is a word problem? So, if you joined us in the morning, little bit of overlap here, but kind of this kind of is okay as well, right? A typical math problem is something like an expression, right? We want to do some calculation, things like that as well. So, and right, so we have just a pretty basic problem. Okay, so right, you might think of this as like 90% times 40, right? Right? So everybody is sharing in chat. That is great, right? We would think of this as an answer of 36 right here, right? And there's lots of different ways you could approach this, right? We'll do maybe some more tricks when we get to some of the more difficult problems from there as well, right? But what is a word problem? And right, this time here, I think I did a little better job of this, right? So how could we kind of rephrase the question in terms of a real life scenario or a real life kind of problem that way as well, right? So Manny's math class recently had a chapter test with 40 questions. If Manny got a score of 90% on the test, how many questions did he answer correctly? Yeah, so we can share the answers and stuff, but yeah, we have slow mode on for a reason here, just so we have a chance for people to participate and the chat doesn't get too crazy that way as well, right? So this question is actually the same in terms of calculation, right? So this is just our beginning example, of course, just showing you, right, that these word problems in terms of kind of how we're working through them, are a lot of times going to be calculations we could have done before, but we have to kind of try to apply them in other ways, right? So we just gave the answer before, right? Here, let me just kind of say times 90 over 100, right? Just as a quick reminder of kind of how you do some of these fractions and percentages calculation. And of course, you do get the same exact answer of 36. So, right, of course, we could do both types of questions, but we're going to kind of focus on ones here where we need to translate into, right, from the words to the math and then coming up with our answer as well. Okay, so next slide here, right? I do want to say again, how do you solve a word problem, right? So kind of very, very important kind of ideas and kind of issues we want to kind of go through, right? If you joined us in the morning, we're kind of reviewing this kind of as well. And so, right, I do want to talk about this quick again. So when we approach a word problem, read it carefully, right? What is the important information? That's kind of important. Is there any unnecessary information, right? What is the final question being asked, right? So these are very kind of important things to do there. If you're taking a test in school, if you're doing a math contest or things like that, right? You want to kind of make sure you're not making silly mistakes this way, right? And word problems really kind of here usually kind of lead themselves to kind of issues with kind of how you would make mistakes along the way too. Okay, so right after you read it carefully, what's important? Can I ignore things? What are the numbers I want to put together? Right, then you can kind of decide on a strategy and stuff like that as well. So yeah, let's focus here on the math. Yeah, so I know people are itchy to get to kind of the problems here, but I want to kind of make us get started here a little bit too. Yeah, okay. And so if we need to slow down it even more, we were at 15 seconds last time. If I need to go back to 15 seconds, I can too. But let's kind of try to kind of allow us to do some problems here as well. Now, just a little bit of intro, right? We're going to do a bunch of practice problems in 2 minutes here, right? But just want to give my quick pitch again. If you want to do more problems like this, right, you can check out one very good site I would recommend and hope you guys visit, right? ZIML.areteam.org. We have a lot of problems here. We have monthly contests. We have books from the old kind of monthly contests. This is kind of a good place to get started for free that way as well. And then also, right, some other things here. A lot of these problems we're going to be doing kind of sample stuff from kind of this mathematical wisdom book as well. Right, so this book has different kind of problems here with some of the things we're going to doing for class today as well. Yeah, so there's other kind of communities, right? We know of, yeah, AOPS as well, right? They have good forums and stuff there too. But we do think that kind of the ZIML site as well has some good practice problems, right? You can do those each day. You're going to get your progress tracked and everything there too. So just another alternative to kind of add to different sites you're kind of visit as well. Okay, so as you've all been waiting for, right, as promised, we're going to do some stuff with problems, right? So here is our first problem. The first couple are, of course, not too difficult. Just remember that you want to not make mistakes as well, right? So here we have, right, 18 blue cars, 12 red cars, 15 green cars. He has boxes that can fit 8 cars each. He wants to store his cars in the boxes, making sure that there are no cars of different color in the same box, right? So one of the things here, right, we need to be careful about is this fact that we're doing no 2 cars of the same color in the same, or different colors in the same box, right? So that's where you want to be kind of careful in this case. And then there's a bunch of 7s and good, showing a little bit of work. So Kevin, thank you for your answer as well, right? When we have kind of the divisions here, we're doing 18 divided by 8, right? So for the blue cars, right, this is 2 with remainder of 2, right? And then we could do the similar calculations, 15 divided by 8, 12 divided by 8, right? And so both of these are 1 with their own respective remainders there as well. And so this is remainder 7 and remainder of 4. So then for each of these colors, we want to round up, right? So this is going to need 3 boxes because those 2 leftover cars need a box. These 7 leftover cars still need a box. And so we add up 3 plus 2 plus 2, giving us a final answer of 7 in this case. Right, so we're kind of rounding up because, right, we need all the cars to go into boxes there as well. Yeah, so right, one kind of mistake here, right, might be, right, we don't want to do, right, so let me put this off to the side here really quick, right, so caution, right, not 18 plus 12 plus 15 divided by 8 rounded up, right? We need to do each of the colors separately as well. Yeah, so that's kind of a good caution to do here, right? You might think a question so easy, right? It is an easy question here kind of as well, right? But sometimes you may think it's a little easier than it actually is. Okay, so let's not worry about who everyone else is, right? Let's just on ourselves and solving problems, please. Okay. Yeah, so we don't need to worry about who other people are. And yeah, we'll try to just kind of work together to solve these problems. So, next question is about Dexter. So Dexter bought 50 limes for $20 and a pound of sugar for $2. He used all his limes and sugar to make 10 liters of lemonade, right? Or maybe more accurately called limeade or something here. But he sold his lemonade at 60 cents for 1/4 of a liter. How much money did he make after he sold all of his lemonade? Okay, so kind of, we basically have 2 parts we want to do here, right? So the thing we want to kind of keep in mind is how much did he spend, and then how much did he make, right? So how much did Dexter spend? Now, right, of course, we're focused on the mathematics, but in doing this kind of problem here as well, maybe if we want to just kind of learn a little bit of economic terms as well, we have $22 he spent, right? These would be called his expenses. All right, so that's kind of the money he spent to make his drink. And then we want to kind of talk about the money he made, right? So how much did Dexter sell the lemonade for? And so then how do we do this calculation there, right? We need to do a little bit of kind of calculation with the amount he made. Do we care about the actual recipe, right? We can argue about limes and lemons or things like that, right? Right? Do we care about what he did? No. We only kind of care about the 10 liters, right? We know he made 10 liters of the drink. That is the kind of only portion that we really care about in that case. So, right, how many servings is this, right? So 10 liters is, right, 40 servings of 1/4 of a liter. And so if he's selling each of those for 60 cents each, so the kind of net amount he makes, right, 60 cents times 40, which is giving us our $24. This would be kind of revenue here. Yeah, so maybe Dexter's doing some false advertising, right? And remember, one of the things kind of is just kind of not really caring about the extra information or kind of useless information there, right? That portion kind of doesn't matter here either. So kind of put together here, we have, right, 24, 22, and so this is our kind of difference of, right, $2 profit. So the 24 minus 22 is $2, and that kind of is our total profit that Dexter has here. Okay. So yeah, let's try to stay kind of focused here, please, and we'll kind of continue working on the problems as well. So we have our first example kind of a ratio as well here. So red, green, and blue candies, right? So ratio of red to green, right? It's good to kind of just start out with how much we kind of know in the beginning. So red to green ratio is 2 to 5. And we know that the green to blue is 3 to 5 as well. So there's different kind of things to kind of talk about here as well. Okay, guys, so we are not going to be worried about other people here. Let's focus on just ourselves. I will start deleting messages when I can and also timing out from the chat a little bit here if needed. Okay, so right, a lot of people are saying the answer is 460 here. So what are the calculations kind of involved in this case? Okay, so couple of different things to do here. One good way to do this is, can we kind of talk about common ratios and stuff here? So we have 3 and 5. Those we can put together into something with 15, right? So 3 to 5 to the 15 portion, right? We can write 3 to 5 as 15 to 25. And then we can write the 2 to 5 as 6 to 25 here, right? So this kind of is our common idea with ratios here, right? So we multiply these two here by 5 to go up, and then these two from the top portion are getting multiplied by 3 to go up. So once we have the full ratio, things are kind of easy as well, right? So the ratio red to green to blue is 6 to 15 to 25. So, right, this total is 25 plus 15 is 40 plus 6 more, right? Well, okay, we don't care about the total in this case, right? Since there are 60 red, we multiply by 10 here. So, right, 60, 150, 250. Now, we have answered the question from here, but we need to then at this point do what? What is the final question asking? The final question is asking their sum, right? So the total number of candies, 60 plus 150 plus 250, is, as people were mentioning, 460. That is kind of good as our final answer there as well. So good, everyone, kind of with our final answer there too. So this was the kind of first example of the ratio that we want to kind of keep here as well. Okay. So good job, everyone, kind of helping answer that one as well. So let's move on then to another ratio problem where we have to do a little bit of work to get started too. So in Mrs. Perth's class, we have a ratio of boys to girls is 4 to 3. In Mr. Penton's class, there are 4 more boys and 3 more girls than in Mr. Perth's class. If there are 67 students in their classes together, how many girls are in Mr. Penton's class? So this one, right, we need to be careful with what's being asked. What are the kind of different pieces we have here as well? Okay. So I haven't seen the correct answer yet, as of least when the kind of chat is kind of happening here. So there are 63 students in total, right, for all of the students combined, right? So both classes put together is 67 students. Right? So a good place to get started here is how many students are in each class. Right? So 63 is in total, right? Mr. Penton's class has 7 more students, right? Mr. Penton's class has 7 more students, right? So 63 minus 7, that will give us kind of 56, right? Then 56 divided by 2 is 28 students in Mrs. Perth's class. So is everybody kind of okay with the reasoning here, right? Because then this kind of gives us a place to get started in the problem, right? So we remove those 7 extra kids. If there are 56 students, then both classes would have the same number, right? We remove 7 kids, the 7 extra kids in Mr. Penton's class, so that gives us 56 left. 56 divided by 2 is 28 students in Mrs. Perth's class. Okay, so what is a good next step then? Well, now we have our 4 to 3 ratio. Since the ratio, right, boys to girls is 4 to 3, in Mrs. Perth's class, then we know how to do this. right? So there are 12 girls and 16 boys in Mrs. Perth's class, right? So that's kind of how we could kind of go about finding Mrs. Perth's class. And then once you have Mrs. Perth's class, this is easy, right? In the sense that we now just add the numbers from there. So in Mr. Penton's class, there are 16 plus 4 equals 20 boys, and 12 plus 3 equals 15 girls. Okay. So that's kind of what we have in terms of our final answer here. Okay. So, right, this is how we kind of have the 15 girls as our final answer here. Now, what is a little bit of an interesting thing to notice here? What is the ratio of boys and girls in Mr. Penton's class? Actually, it's still 4 to 3, right? Notice because that ratio still kind of is increased, 4 more boys, 3 more girls. That preserves the ratio as well. So kind of in fact, this ratio is the same in either of the classrooms, but that doesn't really kind of help us out too much in this case. Okay. So let me see. Okay, let's do one more kind of problem here in terms of some basic ratios, and then we will kind of move up. So let's do one of these from the Mathematical Wisdom book as well. So John is on a business trip with his friends Eric, Nick, and Oscar. Oscar lost all of his money, and so the friends help him out from there. So each gave Oscar the same amount of money, right? So we want to kind of portion kind of everything out here. So every one of the friends helped out Oscar with the same amount of money. Now, from them, it doesn't kind of mean they each gave the same or had the same amount of money to start with. So we have information here about things then from there, right? Eric gave Oscar 20% of his money. John gave Oscar 25% of his money. And Nick gave Oscar 1/3 of his money. Now, what percent of the group's money does Oscar now have? So, does the actual amount of money matter in this case? If these were like super rich people that all had millions and millions of dollars and this happened, or if these were all, not as rich people and kind of giving each other kind of, if this was a school trip, right, instead of a business trip, could this be the same? Okay, friends went on a school field trip, right? The amount doesn't matter, right? So for a lot of these percentage problems, focusing on, right, kind of specific numbers doesn't really matter. Since we want percentages anyway, suppose each gave Oscar, let's just do the maybe school trip example. Let's suppose each gave Oscar $10 right there. So how much money does everyone have then, right? So Oscar has then, clearly he has 10 plus 10 plus 10. he ends up with $30 there. So how do we figure out how much everyone else has then too? Yeah, and so David is suggesting the algebra approach, right? And I just want to point out you don't have to do this with algebra, right? Because since it's a percentage, we only care about kind of that percentage at the end, meaning we can set amounts there, right? So Eric, if he gave Oscar 20%, right? That means he gave away 1/5 of his money. So he had to start with $50. So he gave away $10, and so he has $40. Are people kind of okay with this, right? Because all of the other ones then are pretty similar in this case. Right, so in the end, right, Oscar has 30, Eric has 40, John has 30, Nick has 20. So in total, and yeah, as people were kind of saying, this isn't necessarily people got it wrong, right? But I just want to kind of explain it all the way too. The total amount Oscar has is 30. The total amount of money is 120. So 30 plus 40 plus 30 plus 20. And so then in total, this is 1/4 or 25%. So that kind of is good there as well. Okay, guys, let's try to focus here, please. Okay, so let's do another kind of trick thing. These next couple problems you could do with algebra easily, but I want to kind of try the avoiding algebra case. So a lot of people have heard this kind of idea before. Sorry, not that question. Let's move on to Philip here. Okay, guys, no Brawl Stars here. Okay, so you can easily use algebra here. So yeah, I'm gonna kind of I'm gonna start timing out off-topic answers or kind of questions here. So of course, a system of equations thing is easy and possible, right? Easy and possible to use system of equations here. So, right, no issues kind of setting that up, right? How many boxes are small, how many are large? The sum of those two numbers is 31, and we multiply times 10 and 15. Their sum kind of is 400 there. So, how many of you have heard of the chickens and rabbits method? So this kind of is a method a lot of you guys might have heard of. I want to do this as a kind of example here really quickly as well, right? To kind of show how you do that in a context like this, right? So would all small boxes work, right? No, because 31 times 10 is 310, right? So this kind of is a fix your answer kind of problem there, right? So this kind of is what you have. So 90 less than you actually want, right? This is off by the right answer by 90. And so the kind of key idea here is kind of a switch here, right? So the idea is, right, we do a small to a large, right? What happens when we do kind of a small to large switch in this case, right? Changing one small to large is 5 more nails, right? And so then this is a swap, right? So we need 90 more, right? And so for this 90 more here, guys, so anything, we don't need to ask where each other is from, right? So questions about where we're from, etc., right? Anything off topic will be a time out. So let's try to just focus on the problems here. I know you guys think that it's not too hard, right? But it's not that hard to do it multiple ways as well. So I want to kind of explain those multiple ways as options to give you to solve things as well. So, right, this is another way to get our 18 large, right? And so kind of that is how we can kind of think about things there. And I know it's easy with systems of equations too. This is also easy as well, right? As soon as you read this problem, right, and you're good at the chicken and rabbits method, you can kind of come up with the answer easily as well. Yeah, you can use this method, right? The standard method is, there are 30 animals on the farm, there are 70 legs, right? So every chicken has 2 legs, every rabbit has 4, kind of stuff like that as well. Yeah, so this I would say is fast with the chicken and rabbits method, right? 31 times 10 is 310, 400 minus 310 is 90, 90 divided by 5 is 18. Done, right? And so if you're good at that method, you can just kind of do it in the kind of one step there. Yeah, algebra is good. I'm not saying that it's kind of bad as well, but I want to give that kind of non-algebraic approach, which I actually think is quicker if you kind of get good at it. Okay. So let's do one more example of this, where you have to do a little bit of stuff first if you want to use the chicken and rabbit method. So suppose you have here a chickens and some number of chickens and rabbits. You have a total of 100 feet. And if each chicken was exchanged for a rabbit and each rabbit exchanged for a chicken, how many? You would have 86 feet there. So yeah, if you want to set up an algebraic equation again, that's perfectly fine. So originally, we have, right, 100 feet. After the swap, we have 86 feet. So if instead of swapping, we just did the total here, we have 186 feet in total. So instead of swapping, we just kind of do this together there as well. And if you want to follow along with the algebra, notice that this is going to be very similar to what you're going to do algebra as well. Yeah, so let me just kind of do this total 186 feet here. Now, what can you tell me about the number of chickens and rabbits in this scenario? In this 186 feet, what do we know about the number of chickens and number of rabbits? So this isn't I'm not asking for the final answer in this case, but I'm kind of talking about here in terms of kind of, right, 186 feet. does everybody see for these 186 feet, we actually have the same number of chickens and rabbits here, right? They can be paired up into groups with 6 feet. So because of this, we can turn it into, right, 186 divided by 6 is 31 animals. So, right, the idea here is, and I'm going to erase this in a second, but we started with some chickens and some rabbits, right? And we don't know how many of each, but this gave us 100 feet, right? Or let me just say 100F. Maybe that's better. And then what did we do after the swap? The swap, we had all rabbits. Every chicken became a rabbit. Every rabbit became a chicken here. Right? And so now if we look vertically, what can you tell me about one chicken and one rabbit? This has 6 feet. Right? One chicken and one rabbit, 6 feet. So I'm still explaining where this kind of 31 animals kind of comes from there, right? So what we're kind of noticing here then is in the 186 feet, right? In total, those could be thought of as coming in groups of 6, right? So we have 36 animals, or 31 animals right there. Okay. So, right, that is where the 31 animals comes from. So then from there, right, what can we say? Now we can use the normal chickens and rabbits method, right? So the normal kind of chickens and rabbits method here, right? So we have 31 animals, 100 feet. And right, this is where, again, once you get good at this, you can do this in your head, basically. So, right, 31 times 2 is 62, right, if all chickens. So we need 38 more, right? So we have 38 divided by 2 equals 19 rabbits, and 31 minus 19 equals 12 chickens. Yep, so everybody kind of saying the answer, that kind of is good as well. But that's kind of the kind of strategy we have there. Yeah, this kind of is a classical kind of math problem. It's a classical method that you can use to do a lot of different types of problems. Okay. So I want to do at least 2 more problems. It all depends. Algebra, if you haven't seen this problem in particular before, the algebra method probably is quicker. Or remember, you can always mix and match, right? If you end up with like 2x plus 4y equals 100, and right, 4x plus 2y equals 86, then 6x plus 6y is 186, so x plus y equals 31. Right, so you could do the first portion algebraically. That would kind of get you to that 31 animals as well. And then if you know the direct chicken and rabbits, you're kind of good from there. Okay. Now, 2 motion problems at least before we go. And so the first one is pretty easy to do here. And right, this is just kind of going around a circular track. So, right, Christy and Krista run around a circular track. Okay, guys, let's stay focused here. So couple more minutes, then we're going to be done. So they first meet each other after Christy has run 200 meters. They meet again 50 seconds later. And then we kind of want to go from there. So in terms of when they meet, can somebody tell me what happens when they meet? Right? So since they run in opposite directions, every time they meet, they've, right, combined to run a full circle. Is everybody kind of okay with that? And so what else can we say from here then? Does Christy run any more the first or second time between meetings? Right? So if we look at kind of when they kind of meet each other, right? They're kind of running around the circle. They meet, right? They meet, right? So are not more the first or second times, right? The same. This is kind of the key observation here, right? Christy runs the same distance both times. And from here, it's easy, right? With this observation, it's easy. So Christy's speed, right, is 200 divided by 50 equals 4 meters per second, right? Distance divided by time is the speed, right? And thus, right, Krista's speed is 6 meters per second. There. Yeah, so this is a kind of pretty small track. They're pretty fast runners, kind of stuff like that as well. Okay. So I want to do one more question quick, and then we will kind of call it good. And so for this question here, we have a couple of pieces to kind of talk about as well. So we have Alice, Bob, and Cindy driving from site A to site B. So here kind of is A, here is B, right? This is in terms of the location and stuff like that there. Okay, so almost done here, people. So let's try to behave ourselves the last little bit here. So, right, all of them are driving along the way. So let's take this kind of one piece at a time. So Alice drives at 60 miles per hour. And, right, after 6 hours of driving, we kind of have our meeting. So does everybody believe if we kind of label A 0, right, if this is the kind of point 0 on the number line, Alice is at 360 miles when she kind of meets and passes the person kind of coming the other direction. So this kind of is how we want to start breaking down the information. So Alice, right, 360 miles in 6 hours. So Bob is traveling a slower speed, right? So Bob is going 48 miles per hour. And after 1 extra hour passes, Bob meets up with this person traveling in the other direction, right? So we can kind of do the same exact thing for Bob here, right? So Bob here, this is kind of 7 hours. And so in 7 hours, Bob is going to travel 336 miles. So this is our kind of key situation here. Yeah, guys, so we're almost done here. Let's try to, I guess some people are working on the problem. Let's try to kind of focus on this here. So, what does this tell us in this case? This tells us that the other person, right, the car going in the opposite direction goes 24 miles in 1 hour, right? For the other direction there, right? So this is our kind of key observation in this case. So yeah, people are pretty close here. So in another hour, right, that car still goes another 24 miles. So if we talk about our last person here, right, now it's time to deal with Cindy, right? Cindy is 1 more hour later, right? So now for Cindy, this is going to be 8 hours. And we know that it's minus 24, right? So 312 miles. So if you have all of this information down, then this is kind of everything you need for our final answer, of course, right? So 312 divided by 8, everybody who is saying 39 miles per hour is exactly right. So that's kind of good here as well. Okay. So that will be kind of a good place to kind of stop for right now, right? So want to just kind of quickly remind us a second. Let me go back here to at least the ZIML page, right? So if you want to do kind of more practice problems and things like that, I hope you will have a chance to kind of check out ziml.areteam.org, right? Guys, we will have, right, tomorrow we will have geometry again. So tomorrow's schedule, let me put that up here too. So elementary school geometry, right, 10:30 to 11:15 in the morning. And then we will have the same schedule in the afternoon for kind of middle school geometry. So middle school geometry, 1:30 to 2:15 p.m. tomorrow that way as well. Okay. Yeah, so this kind of is how everything's going to be kind of going tomorrow. And I will kind of see you guys hopefully then. Otherwise, yeah, if you're in our online classes or programs, I will see you guys later on that way as well. So have a good rest of the day. Wash your hands, stay safe, and I will see everybody later on. Goodbye.